Okay, I'm going to talk about the intersection of two planes. So once again, there are three options. The planes can be parallel and distinct. I'm going to use this world atlas and our table to look at planes. Parallel and distinct would mean that one plane is hovering above or below the other. They never touch because they're parallel and they are not the exact same plane. The planes are parallel and coincident would mean that they do touch each other, they're parallel but they lie on the same plane. And then the third option, they intersect in a line. No matter how you rearrange this final plane, they intersect in one line. So if the normal vectors of a plane are not parallel, they will intersect in a line. Let's look at the example. Determine the intersection, it says intersect, determine the intersection of the planes. And you're given two planes, x plus y plus z equals 3, and 2x minus 3y plus 4z equals 6. So first, let's determine their normal vectors. They're the coefficients in front of x, y, and z. I'm using n and m to distinguish between the two. And we can clearly see that because these are not multiples of each other, the normal vectors are not parallel. So we have the third option. They intersect in a line. What we need to do to get that third option is solve for the parametric equations of the line they intersect. The first step to do that is let's eliminate one variable. I always like to eliminate z. So we're going to multiply this equation 1 by 4. So we have 4, 4, 4, and the 3 here becomes 12. And then we subtract the two equations from each other to get 4x minus 2x equals 2x. 4 minus negative 3 is 7y. 4z minus 4z is 0. And 12 minus 6 is 6. So we're left with an equation 2x plus 7y equals 6. Because we are solving for the parametric equations of the line in which these planes intersect, we're going to need a parameter. The easiest thing to do now is let one of your variables equal your parameter. I like to choose x. If we let x equal t, we know that 2t plus 7y equals 6. We can now rearrange that equation for our y. Letting x equal t gave the x equation for our parametric equations, and rearranging here will give our y. So y will equal 6 minus 2t all divided by 7. We can plug those values, our x and our y, back into one of our equations to find our z. I'm going to use x plus y plus z equals what used to be 3 here. And plug those values in to find z. So what we're going to have to do is move everything over the other side. We're going to have 3, so z will equal, I'm going to put everything over 7. So 3 is 21 over 7 minus 6 over 7. And that's plus 2t over 7, and this t will be 7 over 7, minus 7t over 7. So 21 minus 6 will give z equals 15 over 7 minus 5t over 7. These x, y, and z are our parametric equations for the line of intersection. If we were to plug that into our vector equations, we can write this line as x, y, z equals 0, 6 over 7, 15 over 7, plus t, 1, negative 2 over 7, negative 5 over 7.